All right, folks, let's take a look at integration with long division. And the whole goal here is it's going to eventually lead into partial fraction decomposition. But first, we want to look at kind of why we care about that and the kinds of things that we can integrate that are ratios of two polynomials. So here's the general case that we're looking at. If you have something like a divided by x plus b, that can always be integrated with substitution. So for example, if we start with our integral here of a over x plus b dx, and we say that u equals x plus b, that means that the du dx will equal 1, which means that dx equals du. And so then that gives us the integral of a over u du, which if you do the work through this, you'll end up with a ln of u, which is also equal to a ln absolute value x plus b. So anytime that we have a over x plus b, that can be integrated using substitution. So in a more complex case, if the highest power of the, or this kind of basically always works if the highest power of the denominator needs to be less than the highest power of the numerator. And if not, what you're going to want to use is long division. And then you can use that technique that we just talked about on the remainder. So here's our example, is we start with the integral of 3x cubed over x squared minus 2x. So the problem is our numerator is bigger than our denominator. So we're going to start by doing long division. And if you recall that, the idea behind long division is we basically take our numerator, and then we put our denominator here, just like if you were doing it long division by hand. If there's another technique you want to use, that's fine, but you need to use one that will give you a remainder at the end. So I'm going to start with x, so x times x squared, or so I'm going to start with 3x. 3x times x squared gives me 3x cubed, minus 3x times 2x will be 6x squared. And then I'm going to subtract this, and that leaves me with 6x squared. So then I'm going to add 6, so that I get 6x squared minus 12x. Subtract that, and I get positive 12x. I can't do any more division because x squared won't go into 12x. So we add our remainder of plus 12x over x squared minus 2x. So this can be rewritten as the integral of 3x plus 6 plus 12x over x squared minus 2x. Which then simplifies further because we can cancel an x out of all those terms. We get the integral of 3x plus 6 plus 12 over x minus 2. So sometimes if you use long division, it'll kind of clean up quite nicely like this. And then if we integrate that, the 3x will give us 3/2 x squared plus 6x plus 12 ln of absolute value x minus 2 plus c. So that'll be our answer. If I skip through that a little too quick, I'll just redo the last bit here. If you're comfortable with how that substitution went, you can go ahead and skip to the next video. But for those wanting to see the substitution, u is going to equal to x minus 2. So du by dx will equal to 1, which implies that du equals dx. So that last term, integrating that, 12 over u du is equal to 12 ln, absolute value of u, plus c. I just wrote that under myself. So that will be 12 ln of u plus c, which when we plug back in our u of x equals 2, we get the response up there. So that's using long division to get something that can be more easily integrated.